All right, hello, Pretend Classroom. My name is Michael Monroy, and I will be a student teacher today. And today we're going to be talking about solving two-step linear equations using the balance method. So with the balance method, the thing that I want to convey, the thing I want to talk about really is balance. Now, when I say balance, what do you think? You might think of like a scale or a teeter-totter. I like to use scale. So on a scale, if you want to balance it out, you could have nothing on each side of a scale and it would be balanced. Or you could have 10 pounds on each side of the scale and it would be balanced. So that's what we want to do. We want to make sure things stay balanced. Right? Both sides are equal. 10 pounds on this side, 10 pounds on this side. So the same thing is going to apply to equations. On equations, you want things to be balanced. So on a scale, if you have 10 pounds and 10 pounds, and you add 3 pounds here, now this is 13 pounds. So that's not balanced anymore. So if you want it to be balanced, you need to add 3 pounds on this side as well. That's essentially what we're doing with our two-step linear equations. With equations, things have to be equal. Right? Equations equal. So we're going to get our equal sign here, and that's going to kind of be the middle of our scale. And we'll put in some numbers to kind of give you an idea of how this works with math. So we'll do 2x plus 3 equals 11. 2x plus 3 equals 11. So we all know our order of operations, right? PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, right? So when we're trying to balance this out, kind of get this x by itself to figure out what our variable is, right now we have no idea what times 2 plus 3 equals 11. Right? So we need to work backwards from our order of operation to make sure we're isolating this x, get this x by itself, so we know what times 2 plus 3 equals 11. So if we're working backwards, like retracing our steps, right now we're lost with this x. We need to find our way back to what this x equals. So we're retracing our steps. And if PEMDAS is parentheses, exponents, multiplication, division, addition, and subtraction, we need to start with addition and subtraction. So there's nothing being added or subtracted on this side. This side just equals 11, right? This is only 11. But there is something being added on this side, like plus 3. All right? So we need to get rid of it. Get rid of that plus 3. So how do we do that? We subtract 3 from this side. So we have 2x plus 3 minus 3. And because we did it on this side, we also have to do it on this side because we are balancing. So we have to do 11 minus 3. Which brings us with, bring that 2x down. This cancels out. Bring our equal sign down. 11 minus 3 is 8. Bring that down. So now we have 2x equals 8. Now the only thing we have left here is 2 times x equals 8. So we want to get rid of this 2x. Now how do we get rid of 2 times x? You have to divide to get this x by itself. So x is being multiplied by 2, so we can take 2x and divide it by 2. 2x divided by 2, these 2 cancels out. We'll bring our x down, equals, now whatever we did on this side, we have to do on this side. So we do 8 divided by 2. 8 divided by 2 is 4. So now we've got our x by itself, our equal sign looking beautiful right there in the middle equals 4. X equals 4. How do we verify that? Well, we just plugged 4 back into our original equation, which was 2x plus 3 equals 11. So we take that 4, put it in the x spot, and we'll get 2 times 4 plus 3 equals 11. Get rid of this to make things a little bit easier. All right, so we'll take our order of operations and we'll multiply first, figure this out. So 2 times 4 equals 8. Bring your plus 3 down, bring your equal sign down, and it should equal 11. We know that 8 plus 3 equals 11. Bring that equal sign down, and bring that answer down, and 11 does in fact equal 11. Perfect, wonderful balance. Let's work on another one. See what we've got going on here. All right, so now we'll try 3x plus 4 equals 16. All right, so right now our x is lost, and we have to retrace our steps, or retrace our order of operations in order to find out what our x is. All right, so PEMDAS backwards. What do we need to do first? Well, we need to find something that's being added or subtracted first. So again, on this side of our equation, nothing's going on. It's just 16 all by itself. There is something being added here on this side of the equation. So it's that plus 4. So to get rid of that, we subtract. So 3x plus 4 minus 4 is going to equal 16 minus 4. Okay, 16 minus 4 is 12. Plus 4 minus 4 is nothing. Cancels out. We bring our 3x down. So 3x equals 12. Okay, awesome. So now we've got 3x equals 12. So what do we do here with 3x equals 12? Well, we've got 3 times x here. So we can do the opposite. 3 times, so we'll do 3x divided by 3. We can cancel out these 3's. Equals 12 divided by 3, which is 4. Let's bring everything down. Make it easier. X equals 4. Okay, awesome. X equals 4. So that's supposedly what it is, but we need to plug our answer in to make sure that we are correct. So we're going to take 3 times 4 plus 4 should equal 16. Let's try that. Three times 4 plus 4 equals 16. So first thing we want to do is our multiplication, because x is found apparently. X is 4. We don't have to go backwards anymore. We found x. So now we just go through from start to finish. 3 times 4 equals 12. Bring our plus 4 down. Bring our equal sign down. 16 plus 4 equals... Oh, sorry about that. I'm going to do that. We've got that 16 already figured out. It's just 16. So it should equal 16. Up 12 plus 4 equals 16. Bring our equal sign down. Bring our 16 down again. And 16 does in fact equal 16. So we've balanced that out. So x equals 4. Again, not always, but this time again. Alright, let's get rid of that. Let's try something else. Let's do 5x minus 6 equals 14. Alright, how do we do this? Well, right now our x is lost, and we need to retrace our steps. So what do we do first? We've got our scale here, balancing on our equation. And nothing being done on this side, no operations to reverse. So we can reverse some operations on this side though. 5x minus 6. So we've got that minus 6 times 5. We can add 6. Plus 6. And whatever you do to this side, you gotta do this side. So 14 plus 6. Alright, let's go ahead and bring that down to 0. 20. Let's do 5x equals 20. Cool. 5x equals 20. So now we are doing what over here? Multiplying. So the opposite of multiplication is division. So we'll, instead of times by 5, divide by 5. 5x divided by 5. 20 divided by 5. Because whatever you do to this side, you have to do to this side. 5x divided by 5. Cancels these 5s out. And brings that beautiful x down here all by itself. Isolating that x. What we want to do. Put our equal sign down. 20 divided by 5 is 4. Oh, look at that. Beautiful 4. Okay. So x equals 4. How do we know if this is correct? Now we're going to put this 4 back into our original equation and do 5 times 4 minus 6 equals 14. Let's give that a shot. We'll do 5 times 4 minus 6 equals 14. Let's give it a shot. 5 times 4 is 20. Minus 6 down equals down is 14 down. 14. It's looking okay to me so far. 20 minus 6 is 14. Equal sign down equals 14. And 14 does in fact equal 14. So balanced. Awesome. Alright, let's try something else here. Here's a problem for you. Switch it up a little bit here. Let's do, I got it written down here. Yeah, there we go. X minus 8 equals 10. Alright, remember, balance. What do you do to this side? You have to do to this side. I'll let you work on that by yourself. Pause. Like, okay, here we go. So, 6x minus 8 equals 10. So, right now, our x is lost. We need to find its way home. We need to retrace our steps, retrace our order of operations. So first we need to add or subtract. So we've got 6x minus 8. So we can plus 8. So these cancel out. And plus 8 to this side because we are balancing on our equal sign. Which leaves us with 6x equals 18. Cool. Bringing that down. So now, what are we doing here? We're multiplying. The opposite of multiplication is division. So we're multiplying by 6 here, so we can divide by 6 here. So these 6 you cancel out and divide by 6 here. Bring this x down all by itself the way we want it. equals 3, not 4. So x equals 3. Allegedly. How do we figure that out? We plug it back into our equation. All right, so we'll do 6 times 3 minus 8 equals 10. Let's figure that out. 6 times 3 plus, oh, excuse me. 6 times 3 minus 8 equals 10. All right, let's do it. 6 times 3, that's going to be 18. Bring down this minus 8, bring down this equal sign, bring down this 10. 18 minus 8 is in fact 10. And 10, bringing down the equal sign, does equal 10. Balanced. Amazing. All right. So remember, when you have something like this, our 5x minus 6 equals 14. Our x is lost and we need to retrace its steps, so it's important that when you are retracing your steps doing the balanced method, that you are adding and subtracting first, then multiplying and dividing. Order of operations backwards to figure it out, and then order of operations forwards once you plug your answer back in. So, important to minus or add or subtract first before you multiply and divide when you're trying to isolate a variable. It'll make your life a whole lot easier. And remember, when you do something to one side of the equation, you got to do something to the other side of the equation. Right? Because if you just kept adding weight to one side of the scale, it would be unbalanced. If you kept taking weight away from one side of the scale, it would be unbalanced. So you got a bing, bong. Do it here, do it here. You minus here, you minus here. You add here, you add here. And that's it for my lesson today. Thank you for participating. Bye-bye.